Hey everyone, it's Justin again. In the last video, you learned how to factor out a GCF, which was the reverse of multiplying by a monomial, which you learned at the beginning of this unit. After that, you learned how to multiply binomials together. So in this video, we're going to learn how to reverse that process, factoring a polynomial into two binomials. At the end of this lesson, you will be able to factor quadratic functions into their binomial factors. To learn how to do that, first we'll take a closer look at what happens when we multiply binomials. Then we'll define what a quadratic function is before going through two examples together and ending with one example to try on your own. Let's multiply two binomials together first and then backtrack to see what happened. That'll help us understand how the factors in product are connected. First, we distribute the x over to both terms in the other binomial. Then move to the 2 and do the same thing. The two terms in the middle are like terms, so we can combine them and make 7x. Okay, so we got our product. Now what's the pattern here? This last constant just came from multiplying the constants from each binomial. So there's that. And the 7, the 7 came from adding the two coefficients, which were the same as the original constants. So the 7 and the 10 came from the same place, just different operations. 7 came from adding 2 and 5, while 10 came from multiplying them. Oh, right, that new word in the title of the video, quadratic, short for quadratic function. Quadratic describes a certain type of function, kind of like linear or exponential. Specifically, a quadratic function is a polynomial function with degree 2. The product from a moment ago, x squared plus 7x plus 10, is an example of a quadratic function because its leading term has an exponent of 2. So in this video, we're going to be focused on factoring second-degree polynomials like this one, aka quadratics. Now that we've got an idea of how the binomial factors and quadratic product are related, let's try to use that knowledge. Here we have the quadratic function x squared minus 4x minus 21. Since the first term is x squared, that has to come from x times x. To find the constant for each factor, we'll use what we just learned. The constant at the end of the quadratic comes from multiplying the two values together. And the middle term comes from adding those same two numbers. If we can find a pair of numbers that fits both requirements, we'll have our factors. So what numbers multiply to make 21? 3 times 7 and 1 times 21. That's it. Except we don't need to make 21. We need to make negative 21. 3 times 7 wouldn't make a negative number, but negative 3 times 7 would. Or 3 times negative 7. The same goes for 1 and 21. Negative 1 times 21 works, or 1 times negative 21. Okay, so now we've got 4 possible combinations, but remember, that isn't all. The correct combination also adds together to make negative 4. If we add negative 3 and 7, we get positive 4, so that's not the right combination. What about negative 1 and 21? Well, that won't work, because that makes 20. Okay, let's try 3 and negative 7. Those add together to make negative 4. There we go. There's our answer. 3 and negative 7 multiply to make negative 21 and combine to make negative 4. So those are the constants in our binomial factors. Just like before, it's important to know how to check your answer. Luckily, with all factoring, you can check your answer the same way. Redistribute and see if you get back to where you started. X squared minus 7x plus 3x minus 21. Negative 7x and 3x combine to make negative 4x, and look at that. We got the quadratic function we started with, meaning our factors were correct. Here's another one. X squared minus 5x plus 4. We already know how this goes now. We find the two numbers that multiply to make 4, that add together to make negative 5. It's like a riddle. So what integers multiply to make 4? 2 times 2 and 1 times 4. Now we just have to see which of these combinations adds together to make negative 5. 2 plus 2? Nah, that just makes positive 4. So it's got to be 1 and 4, which makes positive 5. Wait, what? How are we supposed to get a negative from adding two positives together? Unless... Oh, that's sneaky. Let's head back over to the multiplication real quick. We used all positives because positive times positive makes a positive. But isn't there another way to make a positive? By multiplying two negatives. We completely missed two combinations. Now let's try adding those to make negative 5. Negative 2 plus negative 2? No, that makes negative 4, but it's negative, so at least we're on the right track here. How about negative 1 and negative 4? There it is, the number we've been looking for. So negative 1 and negative 4 are the big winners, making the factors x minus 1 and x minus 4. Don't forget to check your answer. Multiply these binomials together and see if you get the original quadratic function from that last example. Here's one to try yourself. Pause the video and factor this polynomial. When you finish, or if you get stuck, come back and I'll give you the answer. You might be feeling a little aggravated right now. You have a right to. After all, you can't factor this. It's not factorable. Some polynomials simply can't be broken down any further. We could try to find all the combinations that multiply to make 12 and test them to see which ones add together to make 10, but your paper probably ended up looking something like this. No matter what we try, none of these combinations work because they weren't meant to. This quadratic function can't be factored. Sorry about that. You're right, that wasn't fair. Okay, no more trick questions. This one can be factored. So pause the video now and see how you do. We know that the two constants have to multiply to make negative 8 and add together to make 2. There are a bunch of combinations you can try, but the winning combination will be negative 2 and 4, numbers that multiply to make negative 8 and add together to make 2. So the factors of x squared plus 2x minus 8 are x minus 2 and x plus 4. In the next lesson, we're going to combine the last couple lessons. We're going to learn that some polynomials have both a GCF and two binomial factors. See you then.